we want to determine the equation for the graph of this particular line. And so one tool that we may try to utilize, of course, would be that of slope-intercept form, where we'll need to know the slope of the line, which will be the coefficient of x, and then add to that the y-coordinate of where the y-intercept is located at. So going for the slope, first of all, we'll see that if I choose to find the slope between these couple of points, we can have a rise of 4 and then a run of 7, both up and right or positive directions. So that means we get positive 4 divided by positive 7, so we get a 4/7 slope there. And then for the y-intercept, we can see that right there is where the line is crossing through the y-axis, which happens to be somewhere between 2 and 3, a little bit closer to 3, of course. So that's something that we can't just guess what it is. We want to know exactly where that's at in terms of a fraction, hopefully, or whatever it might be. So that's kind of a question mark in terms of, well, we don't know the y-intercept. So if we don't know the y-intercept, then we're not able to kind of write the equation directly into slope-intercept form. So that causes us to wonder, is there another way that we could go about this? And it turns out that there is. There are other forms of linear equations outside of just slope-intercept form. And one form that's really helpful to be able to write linear equations in a lot of scenarios is what we denote as point-slope form. So exactly what point-slope form is going to require of us is going to require what the name of the form is. It's needing to have a point, specifically a point that is on the line somewhere, and it can be any point, any xy coordinate that you know, and then also knowing what the slope of the line is. And if you have those two things, you'll be able to write the equation of the line. So ultimately, it really just kind of works like this, that if we can determine a point that's on the line, so like 2 and 3, and then the slope of this would be up 1 over 2, so the slope would be 1/2, then you can use those things and plug it into point-slope form, which is given as follows. So the black letters, x and y there, are your variables that will remain as they are. So the red and the blue there are denoting a y-coordinate and an x-coordinate, and those will correspond exactly to the known point that you know is on the graph. So since we know the point 2, 3 is on the graph, that's why 2 and 3 get substituted in right there, and then you'll see that the slope is right there. So point-slope form is y minus y1 equals m times the quantity of x minus x1, just knowing that x sub 1, y sub 1 is the known point, and m is the slope of the line. So to help you understand where point-slope form is actually coming from, so keeping in mind that point-slope form is y minus y1 equals m times x minus x1. So suppose that we do know the coordinates of a particular point on a line. So let's say that we actually know what the x and the y are of that point. So if I know them, I'm going to call it x sub 1, y sub 1, whatever those numbers might be if we know the values of those points. And then if we just pick any other point on the line, but we may not know the coordinates of those points, just any other xy point, then we can relate these 2 points together with one another because we know how to compute slope between 2 particular points, because really all that slope is it's taking a y coordinate minus a y coordinate, so y minus y1, and then over the x coordinate minus the other x coordinate, and that's going to be able to determine the slope of your line. And so that's really just using slope formula, and then just by doing one small thing to both sides right here, by multiplying by the quantity of x minus x sub 1 to both sides, then that's really just going to kind of cancel out, and then multiplying this side by the quantity of x minus x sub 1, what we end up getting then is that y minus y sub 1 is equal to m times x minus x sub 1. And there's exactly where point-slope form is actually coming from. So putting point-slope form here kind of into action a little bit, I want to show you a couple ways in which we can write a linear equation. First of all, going into slope-intercept form with this one. So if you can use slope-intercept form, meaning that you know where the y-intercept is and you know the slope of the line, that's the easiest form to kind of go with. And that's exactly what we can do right here, because to go into slope-intercept form, you just need to know the slope and where the y-intercept is. And so it turns out that if you follow the pattern of this line, it's up 2 over 1 all the time in a positive direction. So you have a positive 2 slope, and then you'll see that right there its y-intercept is exactly at 15. So it does turn out that y equals 2x plus 15 will be the equation for this line, and that's doing that just using slope-intercept form. Now, it turns out that we can also use point-slope form. So point-slope form being that we can take y minus a known y-coordinate equals the slope times the quantity of x minus the known x-coordinate of that point that you chose. So obviously this guy right here is going to be known because it's still going to be 2 for the slope. So that can easily just be substituted in since that was known from what we did just previously. So when we use point slope form, you can pick literally any point that you want that's on this line. So like for example right here, that's clearly a point on the line whose coordinates are -6 and +3. So when you substitute in these values, then you'll have to recognize the fact that you're always subtracting those coordinates, which means sometimes you do subtract negatives. So the nice thing about this is that right here is where you're going to plug in the x-coordinate of the point, and right here, this -6 is the x-coordinate, so you're going to plug in -6 right there. Now because you're subtracting a negative, right, that really turns into plus ultimately. And then when you substitute in right here, it's always the y-coordinate of the point, which means that you would substitute in 3. So this right here would get you the equation, and then you're always able to take something that's in point-slope form like it is right now, and you can solve it to get the y alone, because what that does is it gets it into slope-intercept form. So if I leave y minus 3 as it is for now, and then just use the distributive property, we get this, and then I can get the y alone if I add 3 to both sides, which means that y is going to be equal to 2x plus 15, and of course you get the same thing. And so no matter what point you choose on a line, you're always going to get the result that you want. So like right there is -211, for example. So if you use that point instead, where you did y minus y equals m and x minus x, you end up getting y minus 11 equals 2x plus 4, and then you add 11 to both sides, and lo and behold, of course, you still get y equals 2x plus 15 out of that. So when we're using point slope form, so we're trying to write an equation of a line, but we want to write it in point slope form, then really you just need to know a couple of things. You need to know the slope, right? That's why it's part of the name of the form. And then second of all, you need to know a point that is specifically on the line. So not just any arbitrary point, right? It's got to be on the line, and then you can write the equation of that in point slope form. So right here, what is an equation in slope-intercept form of the line that passes through -3, 2 and has slope -10? So it's saying, let's write this in slope-intercept form, right? We want an equation in slope-intercept form. But to go in slope-intercept form directly, you'd want to have a y-intercept, and that point right there is not on the y-axis, right? So we don't really know the y-intercept. So just because something's asking for slope-intercept form doesn't mean you need to start out there, because what we know about the line right now is we know its slope, and then because it's going to pass through that, that's going to be a point that's on the line, which means we have enough to write this in point slope form, and then just from point slope form we can solve that to get y alone, and then get it in slope-intercept form like it's asking for. So if we use point slope form is just y minus the y coordinate, which is equal to m times the quantity of x minus the x coordinate, just like that. So I'm going to change that subtracted negative to a plus there, and then we can just solve this for y. So first of all, y minus 2 equals -10x minus 30 using the distributive property, and then if you add 2 to both sides, you'll get y equals -10x minus 28, and that right there would be in slope-intercept form like it was asking for, since it wanted it in mx plus b form. Whereas in right next door it just says write an equation for a line, and it doesn't specify like say, hey, get it in slope-intercept form or point slope. It just says write an equation. So as long as you have an equation that's for the line and fits these characteristics, you're good. So if you write it in point slope form, you could probably just leave it or whatever. So in this case, you know the slope, and it also contains a point. So yeah, you can just use point slope form. So y minus y is equal to m, and then parentheses x minus x. And then you can just leave it like that. You might want to just make that subtracting a negative turn into a positive. And so now this guy should be a little bit familiar for you, because we looked at this guy before, because this was the one that had the slope of 4/7, right? So we know that y is going to equal 4/7 x, but then this guy was the mystery because its y-intercept was somewhere between 2 and 3. So if we can't write it directly in slope-intercept form, but if you have enough information to go in point-slope form, then you might want to do that, and we do have enough information for that. So we do know that the slope is 4/7, and then just pick any point that's on the line. It does not matter which point that you pick. So if you pick that point, that's great. That's got coordinates -10 and -3 for the y. And so then just knowing one of the points on the line, the slope, then you can just write it in point slope form, which would mean that y minus y is equal to 4/7 times the quantity of x minus x. So because both of those coordinates were negatives, then when you plug it into point slope form, you actually get all kind of positives there. And then you're able to get this into slope-intercept form if you wanted to by simplifying this out. So by distributing, first of all, you're going to get 4/7 x, and then 4/7 times 10 would be 40/7, and then we have y plus 3 is equal to that. And so to kind of get the y alone at the end here, you can go ahead and subtract 3, and then subtract 3, and then you'll notice that these guys right here are going to be like terms because they're both just numbers. But to do so, you're going to need a common denominator. So you're going to have to turn that 3 really into 21/7. And then you can go ahead and take 40/7 and subtract 21/7. And that's going to give you a positive 19/7. So therefore, y would be equal to 4/7 x plus 19/7. And so that would give you that that y-intercept right there. That's somewhere between 2 and 3, a little bit closer to 3 than it is to 2 ultimately. So as you're looking at writing equations from graphs just like we did, if you see that the y-intercept is not going to be a very nice number, then you're going to have to go into point slope form to be able to write the equation. And so if you can find some nice coordinates to find the slope first of all, that would be really nice. So I found a couple of points. Yeah, so it looks like this slope is a rise of 2 and a run of 3, so we would know that the slope is 2/3. And then you're just going to have to pick a point somewhere on the line. This would be a really nice point because it's got a 0 in it, because it would be 2, 0. So then when we take that point and that slope and put it into point slope form, you're just going to have y minus y equals m and times the quantity of x minus x. So on that left-hand side, it turns out really nice because you just get the y. So just y equals and then distribute. So 2/3 x and then minus 4/3, and that gets you it the equation there in slope-intercept form. And basically kind of the same thing going on here. You just got to find the slope somehow. So it looks like it's going down 1, 2, 3, 4, 5, and then 4. So down 5 over 4. So it's going to have a -5/4 slope. And then in terms of a point, maybe we can choose that one right there, which is 2, -1, and then you can write it in point slope form. So y minus y equals m, and then parentheses x minus x. And then we want to write it in slope-intercept form like it's asking. So just a little bit of solving. So if you distribute first, you get -5/4 x, and then negative times negative is positive, 10/4. I'm going to rewrite that though, because 10/4 can be reduced down to 5/2. And then on the other side, we still have y plus 1. So to get the y alone, then you're just going to need to subtract 1. And then to subtract 1 on this side, I'm going to write 1 actually as 2/2 there. There we go. So that we can combine those together. It'll be positive 3/2 when you combine those. So we get a final result there of y equals -5/4 x plus 3/2.